We're working with the RT Prac exam from November 2019, and this is for grade 12. And we, with the last question, we're on the last little bit, so question 4.2 of this paper. So our previous question, we displayed the maze. We're dealing with the mazes. There are 3 different mazes, and we basically load the maze into an array called ARR maze. And we also display it in this little rich edit control. So we can see the maze. So that's what happens in question 4.1 that's done in our previous video. Now in 4.2, we need to find the longest corridor, not the Mr. Longest corridor, just the longest corridor. Okay, so this refers to the maximum number of consecutive horizontal open spaces. Phew, because if we had to work it out going down, that would be quite complicated. Horizontal means going across. The way I think of it is that's the horizon. You don't look at the horizon up and down, you look at it left to right. So horizontal spaces. So we're looking at the horizontal dashes display. So we want to determine the maximum number of horizontal spaces in a row. Display the maximum number of horizontal spaces as part of the output, and then display a list of the rows, there could be more than one, that contains the corridor with the maximum number. So for maze 1, you can see that the longest corridor is 7 spaces. So for example, 2, 4, and 13 have 7 spaces. So number 2, 1, 2, 3, 4, 5, 6. There's one, and then number 4, 1, 2, 3. So that's quite complicated. We've got to try and work out the number of consecutive spaces. So how do we do this? Well, there's lots of parts to this. First of all, it's trying to determine what is the longest number of spaces for that particular row, and then we'll work it out and save it somewhere, things like that. So the way you would do it is that you would, every time you find a dash, then you will basically say that's now the longest space. And then if you find another dash, you add on to it. So you're keeping track of how many dashes you find, okay? And every time you find a dash, that's your new longest. That's your new longest corridor. So we record it as the longest corridor. No, that's our new longest one. That's our new longest. The moment we don't get a dash, okay, we would have recorded our previous longest there, but we can reset our dash count to 0 because we would start a new corridor here because our longest corridor could be the second half of that line. So we're going to have to keep track of all these dashes, and every time we find a non-dash, then we're going to, okay, we can stop. We're going to start again, counting the dashes again from the next line, and so on. So we know that this has quite a few. How many lines are there? There are quite a few little dots there. We're going to loop from 1 till the length of obviously that row. Probably, yeah, the length would be the best way. And we know that there's 16 lines and everything, but there is a row count for the array. So let's go into this. This is quite a complicated one. So let's see how we go. So first of all, we're going to have to loop through each. Let's just do one line. That would be my suggestion. Let's just get one line going. So we're going to work with a for loop that goes from, and this will be the row, or the column, actually the column, because it's going from 1 till the length of what do we do? So let's pretend we're on maze 1. So we want the second line. So I'm going to crook the books a little bit here. I'm going to have a column, it's a row. Let's have a row variable s row. As I said, we're running out of time in an exam. We want to make sure you get all the marks, and we obviously need our column integer. And we're going to say s row is equal to array maze, and we just want the second one. We're not going to do this officially, but we're going to adapt this one. So this will just get the second row of the maze. We don't want the first one because you can see there are no columns in the first one. So get the second row from the maze. So we're going to go from 1 till the length of s row. Okay. And what do we want to do? We want to count the dashes. So we're going to have some sort of count that's going to count the dashes. I'm going to say dash count. Okay. So when we start this row, we want to set our dash count. When do we want to set it to 0? We would set it over here, our dash count at the very beginning. We're going to set it to 0. And we're going to check each and every value in S row at position R col. That's what we're going to do. We're going to say if S row R col, if that is a dash. if that equals to a dash, then what do we want to do? Then we want to increase our dash count, because we found a dash. We've got 0, now we've got a dash count. So our dash count must be increased. So we're going to increase it. I'm trying to think of this out as I go along, so let's try to work it out. But our dash count, we're going to increase it. So now we have 1. And we're going to say, hey, that is now our new longest one, if it is our longest one. Now we need to keep track of our longest line. So that's another variable. We're going to have variables up the yazoo here. So we're going to have a max line. That's the max number of dashes in the line, and we are going to set that to a very, very small number. So our max line is going to be set to a very, very small number so that we always beat it. Okay, you can set it to 0 even, that's fine. So if my r dash count at this moment, if it is bigger than my max line, then I've succeeded in finding a corridor that's longer. It might still be longer, it might still get longer, but that's fine, because every time if we find a dash on the next line, it's just going to increase it and going to reset the max to the new max. So if I find the max line, I am going to say, okay, now this max line is equal to my r dash count. Okay. So if I can basically explain what's happening here, if I've got a line that looks like this, like you see the dashes, and then there's a dash, and then I want to put a hash, and then dash, dash, and then a hash. Okay, so let's look at it like this. So our dash count is -9, and our dash count 0. So we go, look, there's a dash. So we have found 1. 1 is bigger than our max line. So our max number of dashes is a 1. Then I'm going to find another dash. So we've increased our dash count. Now it's 2. 2 is bigger than 1. So now 2 is our longest count. Now we've got a 3. 3 is bigger than 2. So 3 is now. Now we found a non-dash. So when we find a non-dash, if it's a dash, but if it's not a dash, so this is all there. And that's the end of the if statement. If it's not a dash, then we want to reset our count, our dash count, back to 0, because we need to start counting the next corridor from the beginning. So we found a non-dash, so our dash count goes to 0. So now we found 1. That's not bigger than our 3 that we previously had. Then we find another dash, that's now 4. That's not bigger. Then we find 3, that's the same. Now we find 4. Ooh, 4 is now bigger than my current max line. So that becomes my new maximum number of lines. Then I find a non-dash, then we set it back to 0, and then you count on, so on. So that's how we are determining how many dashes, or how many consecutive dashes we have in that particular line. Okay. So that's what we're doing over there. Okay. So once we do that, what do we want to do? So this is only going to work for that. So that'll work for each row. So now this whole thing, we want it to work for every line in the for every line that's in that maze. So we're going to have a loop over here, which would be our row count, which is going to go from 1 to however many rows there are. And I think there's a row count variable. Is it row count? I think it's our row count. Yeah, let's declare our row. Yeah. So all of this is going to happen. Boom, boom. All of that's going to happen inside of this row count. Okay. Now this is the end of the R row loop. Okay. So for each of those, we need to get S row. What is S row? S row is going to equal to whatever's in array maze, not max maze, at position R row. Okay. So, for example, if we've got that line, so first we're going to go through each line individually. We're going to determine however many dashes, consecutive dashes there are, is the max for that row. So then we need to record which is the biggest of that. So this max line only records what's the biggest number of dashes for that line. And at the end of this for loop, once we get to the end of the row, or end of the column, sorry, and the whole line, once we get to the end of the line, so we check each thing, boom, 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 boom. Once we get to the end, once we get there, our max line will have the value of the number of dashes, the consecutive dashes for that line of the most. So in this case, you see there's a 1, 2, 3, 4, 5, 1, 2, 3, 4. So 7 would be the answer for this line, because 7 is the number of consecutive dashes for this line that is the most. So that's what is going to be in our max line. So once I'm finished this loop over here, this loop here, boom. Which loop? That's the col loop. So there, this is the right one, boom. No, that's the wrong loop. That one must be there. So this is the end of the col loop. So once we've ended this column loop, which is this one over here, boom, then we are going to say, okay, we now know the number of dashes for this line. So I need to record the max for out of all of them. So I've got a new max. Oh, this is complicated. So before we even start, I'm going to set our max, and this is going to record the maximum number of lines for the entire maze. So set this to a very small number. So our max line is finding the maximum number of dashes for just one line. So in this case it would be 7. In this case it would be 1, because in this case it will be whatever that length is. I think it's also 7. In this case it would also be a 1. In this case it would be whatever that is. Okay. So that's what it's recording. Our max line is recording the most number of consecutive dashes for each line. So we want to record which of those 16 lines has the number that's the biggest of all. So we set our max to -999, and once we found the max line of the entire line, then only over here can I say if our max line is bigger than my R max. Remember, max line is the number of dashes for the line. R max is the longest set of lines for the entire maze. If that's true, then I'm going to set R max to R max line. So I can record what is the biggest line of the whole thing, and then it's going to shift up here, boom, and actually, yeah, that must go there. Our max line must always be reset when we start a new line, because that's why we set our max over here, because our max is for the entire maze, where our max line is just for each line. So that's why when we start a new line, we reset our max line to a new default. Okay, so let's just, for interest's sake, show message into string R max over here, so we can see what the maximum line is. And we know that the one answer for this one, for maze 1, 7 spaces is the most, and for maze 3, 11 is the most. Okay, so let's hope it works, please. So let's test it. So running. So that will help us determine what is the value for the number of dashes that's the most for the entire maze. So if we select maze 1 and display it, now the longest corridor should be a 7. So we're getting the right result. And if we do number 3, we also get a 7. But it shouldn't be 7. It should be 11. Was it 11? Oh, I think I didn't load it properly. Oh, there we go. I loaded it. Ah, there's the 11. Okay, phew, I nearly got it right there. Okay, so we know that we're getting the right value for it. Whew. So if we get the right value, we can say longest corridor with 7 spaces in a row. So we're going to type that now over here. So after we've done the max line, instead of doing that, we're going to say, okay, we're going to say rich edit .lines.add, and to save time, I'm going to go pre-write that line quickly. So I just type the text. We're going to type the text either side, and we're going to display max. And that's a int to string. So that will display that. Okay, so we now know what the longest line is out of the whole maze. So we can know that this one's a 7 and we know this is 11. Now we're going to write down all the lines that meet that criteria. So how do we do that? There could be multiple ones. Now because there could be multiple ones, instead of just recording it when we find it, because it would be easier when we record the max line to say what was the row that what column or what row were we at? That's one we were going to record. What I'm going to do is I'm actually going to create another array here. Let's call it array max. Okay, let's call it array max. It's an array that's going to go from 1 to our row count, and that's going to be of integer. Okay, so what I'm going to do is every time I find the max value for each line, so the max line will be at the end of this loop. We will now have what's the longest line for this line 1, and then line 2, and then line 3. I'm going to record that into array max. So over here, so we record that. Okay, it's a new line, but irrespective, we can say array max at position at the row that we at. So our row. So at row 1, so the first time we do this, 7 is the whatever. So for this maze, that would be the longest. 1, 2, 3. Well, for the first line, there'll be 0 dashes, and then we go 1, 2, 3, 4, 5, 6, 7. 7. So 7 will be stored at position 2. So we're going to store our max line. So this array max, will have 1 to 16, and it will store all the max lines for each line. So this would be a 0, this would be a 7, this would be a 1, this would be a 7. So it will store the maximum line. So once we've got that, what's nice about that is that now that I know each and every line's max, what I can do here, right after we displayed the max number of spaces, we know what the max is. So I'm just going to loop through that array. So we can use row again. Row, yeah, our row is fine. We're going to go from 1 to row count. We're going to go through my max array. And I'm going to say if the value in array max at position r row is the same as the r max. So if 7's the max line, and the max line for this row is 7, that means this is one of the rows that has 7 spaces in a row. Then what I'm going to do, I'm going to say, well, rich edit dot lines dot add, and what are we going to add? We're just going to add the row, so a couple of spaces and then the row. Okay, so that's what we're going to do. So I'm going to add a couple of spaces and then add whatever this row is, our row. So row 1, row 2, but that needs to convert from an int to a string so it can be converted. Okay. So just to recap, so what we're doing, if we just imagine over here, imagine this is array max. Over here, we're going to go through, there's no dashes there, so there's going to be a negative 999 max there, because that won't change. Now over here, we're going to go, what is the maximum number of lines in a row? And we worked out a 7, and we made that our max is now a 7. And then when we come here, this is going to be a 1, because the maximum number of consecutive is a 1 in this case. It doesn't beat my R max. This one is a 7. It will be the same. So it doesn't beat it, but it's close enough. This is also going to be a 1. This one's going to be 1, 2, 3, 4, 5, 6. 6 is the max in this row. And then this one's going to be a 1, and so on and so on and so on. And so once we've recorded the max, at the end of this, we can say, hey, 7 is the max out of all of them. Then we're going to go through all these lines and go, okay, this is array max. That's a 7. Go record line 2. There's a 7. Go record line 4, please. So that's basically what we are doing. Now, I just want to get rid of this because we don't actually want all this text over here. Okay, so we don't want all this. So I'm just adding garbage here, but if you can get the idea. So let's run it. Whew. This complicated equation is complicated. So we're going to load maze 1. Boom. Okay, we know that the max number of consecutive lines is 7. Longest corridor 7, and position 2, 4, 13. And if we do number 3, just remember to load the array. Yes, it's working. And if we do number 2, okay, that's wrong because we didn't display the maze. Now we display the corridor. 8 spaces in row 13. So if we go to 13, there you can see it's definitely got a long sequence there. So that definitely seems to be right. Okay, I think that's going to be one short there at 50. Okay, so there we go. There we got the result. So just to recap, what we did was, if we look just at this loop here, this treats just one line. Just look at one line of the maze. That's how I did it. I just take one line and then we expand it, then we expand it. For this column, we go from 1 to the length of it. every time we find a dash, increase dash count, and if that value that we just increased, if it's bigger than our recorded max, then make that the new max. This is recording the most number of dashes in a row for just the line. The moment we don't find a dash else, we set the dash count back to 0, because once we go find one, boom, oh, no. Now we're back to counting from 1 and so on. So that's what's happening there. Then once this loop has done, once we finish the row, we record that max line, so we know what the maximum number of consecutive dashes are for that line at that particular line. So at position 1, record how many consecutive lines there are. Position 2, record how many maximum dashes in a row there are for that line. Then we say, okay, we got the max line. If that is bigger than our current max of the total, then that means we've got a new record. It broke the record. It's got more dashes in a row than any of the previous lines. Then we record the new max for the entire maze. And that is why we default the R max outside of everything, but our max line over here gets reset whenever we start a new line, because we want to find the new max for this line. So that's why we reset it there. Okay, so if that makes sense, if you get it all, then well done. You are amazing. Get it? Because it's a maze. It's about mazes. There we go. Whew, that was a tricky question. But if you can the tip to this question is, if you are stuck with time, just get what you can do. So get the code. You know there's going to be loops from 1 to whatever, 1 to the length. Just keep writing those things down, getting little bits, get little bit chunks working, and that way you can accumulate your marks. For more videos on exam papers, you can go to our YouTube channel. Please click that subscribe button, follow us on Twitter and Facebook, leave a comment. We'd love to hear from you. And remember, don't do it the long way, do it the Mr. Long way.